Hello everyone and welcome back to the channel. Today we're going to be looking at a 2000 watt pure sine wave inverter from Redodo. So they're not only just batteries anymore. Let's go ahead and open it up and see what we got. Alright, right when you open it up, here's the inverter. Let's take these off. And it also comes with some cabling, looks like some mounting hardware, and a product manual. Okay, right off the bat, I like how they are keeping to their design, an all white inverter. It clearly labeled what its powers are. 2000 watt inverter, it's a 12 volt inverter. It's going to run between 110 and 120 volts AC at 60 hertz, and it says that it's pure sine wave. Let's see, there's nothing over here and nothing over here, nothing on the bottom. Over here it looks like we have some sort of display, a power button, and two, it looks like 15 amp outlets. On this side there are the positive and negative terminals with these caps, which that's pretty nice. I like how they clip into place. That makes it so it's a little bit better of a safety feature. And then it looks like we have two fans for cooling. I'll go ahead and put the weight and the dimensions on the screen right down here so you can see that. First impressions, I do like the fact that it's like a powdered, I don't know, it's not powdered, but I like the feel, like the paint. I don't know, it feels, I like the rounded edges. There's not like a lot of hard corners, so it's all round. So I like the design of it, it's pretty nice. It looks like it has M8 terminals. So let's go ahead and hook this up to a battery and turn it on. All right, to connect up this inverter, we're gonna go ahead and use the Redodo 100 amp hour mini LiPo battery. And we're going to go ahead and use the cables that came with the inverter. Now, I was looking at these cables, and they're actually 4 separate cables. They are rated for 105 degrees Celsius, and they are 8 gauge cables. So that's 4 8 gauge cables all connected together. Now, the ends are pure copper, which is really nice to see. But these cables are only really rated for around 100 amps. So that'd be perfect to use these cables with a single 100 amp hour battery that can handle up to a discharge of 100 amps. That's what these cables are made for. These cables aren't really made for the full 2000 watts that you can get from this Redodo inverter. So since we're using a single battery, we're going to go ahead and just use these because they're perfectly safe. I got the Redodo inverter all wired up. I did notice that these little plastic covers, they are a really nice feature, but they feel pretty flimsy. Like I feel like I could just break it if I just bend it a little bit too much. I don't know if there's really anything you can do about that. They need to be flexible, but just keep in mind that these are they're probably not going to last for years and years and years. So, but they are, I don't know, quite easy to put on, and they're a really nice safety feature. So I definitely recommend using them. Okay, and then when you first turn it on, it does show you a battery percentage image, like a little picture, and it shows it at 100%. It's probably going by the voltage, so if you're using lithium iron phosphate battery chemistry, I wouldn't take that for 100% true. It does show the voltage of the battery currently, and it shows it at 13.2. And it also switches between that and the AC voltage, which is set at 110 volts. On the bottom here, it shows that it's at 60 hertz, and that it says 0 watts, so that is the wattage that is being output through these 15 amp outlets right here. Okay, so the next thing I'm going to do is just grab a heat gun, and we're going to do a 10-minute test just to see if we're going to run a heat gun at like 950 watts, for 5 or 10 minutes. So let's go do that. Okay, I got everything all ready to go. It's all wired up. I got my heat gun, got my timer. So let's go and just click this heat gun on and start the test. All right, heat gun's on high. And it shows here that we are using 983 watts. And the battery is holding at 12.3 volts. Let's go ahead and start our timer. All right, we're gonna let this run. And while this is running, I'm gonna go ahead and check the amperage of the cabling and also the voltage of the battery to see how accurate this little display is right here. Okay, the monitor right here says the battery voltage is 12.2, but I just took a reading and my meter says 12.45. So there's a slight variation right there. Let's go ahead and check the amperage of the cabling. 91.6 amps. So if I multiply 91.6 amps times 12.45 volts, I'm actually getting 1140 watts coming directly from the battery. And this is showing 982 watts. So I'm guessing this is what the heat gun is actually using and not what is being pulled from the battery. So if I do 982 watts divided by what the battery is actually pulling, which is 1145, I get 85.7% efficiency rate. Okay, this thing's been running for 10 minutes. Let's go ahead and turn it off. And you can hear the fan on the Redodo is on right now, so it's actively cooling the unit, which is a good thing to see. I want to say that fan started right around 9 minutes, so it must be where it waits for the internal temperature to be at a certain point, and not the amount of wattage that you're using. So that's actually kind of good. That saves on efficiency. So it's good to see that this can run, a half-size load for 10 minutes. I'm sure it can run it for as long as you need. So the next thing we're going to do is we're going to go ahead and put a couple more batteries on it and juice up the load a little bit higher and see what it can do. So let's go do that. Okay, this next test that we're going to do, we're going to be doing a 2,000 watt load, and we're going to see if we can power that for 5 minutes. And we're going to check our wiring if we need to for hot spots, or see how the inverter is doing. In order to get that 2,000 watts, I had to add more batteries to my bank because that one 100 amp Redodo battery wouldn't be able to sustain 2,000 watts. So what I did was I was like, you know what? I'm just going to grab a couple of 50 amp batteries and put them all in parallel. So what I have is my 100 amp Redodo in parallel with a Time USB 50 amp and a Power Queen 50 amp battery. So this should be able to handle 200 amps with no problem. And the wiring that I'm using is going from the battery bank to the inverter is the same wiring that I had before. So we're going to be kind of pressing that wire also, just to see how it performs. Because usually the wiring that comes with an inverter, you don't want to use it because it's always undersized. But we might as well use it because it came with it, and we might as well put it to the test. So what I'm going to do is I have my heat gun, and I have this 1500 watt heater right here. So let's go ahead and turn this on high, and I'll start the timer, and we're just going to use this watt meter right here on the unit itself. So we're gonna watch that for trying to get close to about 2,000 watts, and we'll start the test right now. So let's go ahead and turn this on high, and the display shows it's switching between AC and the DC voltage. It's showing 109 volts AC, and it's showing 12.3 volts DC. It's also showing 1,266 watts being used right now. So let's go ahead and turn on the heat gun on low and see where that gets us. All right, now we're at 1,645 watts. So let's go ahead and turn this on high, see where that gets us. And now we're looking at 2,170 watts. So let's go ahead and just keep it there and see if it can do it for 5 minutes. The fans on the inverter already kicked on. So we're just going to let it run, see what happens. I also wanted to show you that we are actually pulling 126 amps through these cables. Oh, actually, I didn't have all the cables in there. We're actually pulling 220 amps through these cables, which are not rated for this amount of amperage. So we're going to look at it through a thermal camera and see what kind of heat we're looking at. Okay, we're looking at the wiring on this camera, and we are looking at 150, about 150 degrees going on right here. Yeah, it feels pretty warm. Let's see, over here on this one, we're looking at 156. On the back of the unit, it's about 150 as well. All the rest of the cabling over here, that looks like to be 113 going to my other battery. But this cable right here, the one that's right in the middle, it's not hot at all. I mean, it's 85 degrees. I mean, that's room temperature, but the rest of them are getting pretty warm. The unit itself is staying relatively cool. You can see the heat gun right there, which is nice and hot. See that? Yeah, we're up to 160 degrees Fahrenheit. And you can definitely feel this cable is warm. All right, well, it ran 2,000 watts for 5 minutes. That's impressive. It didn't shut off at all. Heat-wise, this terminal right here is about 167 degrees. But the unit itself, it's a little warmer back here, but we're just looking at about 100 degrees. That's not bad at all for running its full capacity for 5 minutes. Okay, now that we determined it can run 2,000 watts for 5 minutes with no problems, the only problems that I really had were the improper cabling. And so if you are going to run 2,000 watts continuous, I would recommend, first of all, not using a 2,000 watt inverter in general. You should go 3,000 or probably even 4,000 watts. But the inverter itself handled it just fine. And I wanted to also let you know that in standby mode, with just the inverter turned on with nothing plugged in, it uses about 0.45 amps. So you're looking at at 13 volts. You're looking at right around 6 watts. So 6 watts of standby power is consumed from this unit. All right, the next thing that we're going to try to do is, it says that it can do a surge up to 4,000 watts, and that's like 312 amps at 12.8 volts nominal. I mean, I don't have anything that can do that number, that 300 amp number. I do have a table saw that I'm just going to try to start up, and we'll see if it can do it. My problem might be my battery bank might not like that amp surge, and it might pop before the inverter ever would. So, but we're going to go ahead and try it anyway, just to see what happens. Okay, well, I have my table saw down here. I have it set to record the maximum amount of amperage coming from the DC side. Like I said, right around 312 amps is 4,000 watts, I believe. 4,000 divided by 12.8. Yep, 312.5 amps. So I'm just going to kick this on. We'll see what happens. That only recorded an amp spike of 144 amps. That's kind of disappointing. So I'm going to try something bigger. Okay, I was pretty disappointed with that table saw. I mean, 144 amps, that's no big deal at all. So I'm going to go ahead and try to power up that guy right there, my shopsmith. He's been known to power right around 350 amps on surge. So let's go ahead and try that and see if we can capture anything, if it will even turn on. If it turns on, I'll be super surprised. So let me go ahead and give it a shot. And yeah, the meter only registered 82 amps, but the inverter was not powerful enough to pick up all the amperage that was needed for that drill, or for that shopsmith. So what I'll do is I'll go ahead and plug that heater back in, and we'll run it. We'll run it on low, and then we'll turn on that table saw, and we'll see what kind of amperage we can get from that. Okay, our max now shows 1.4 amps. So let's go ahead and turn the heater on low. And it's maxed out at 56 amps. Let's go ahead and turn on this table saw and see what kind of amperage we get now. All right, still we only got 178 amps of surge. So I guess all we have to do now is let's put the heater on high and then turn on the table saw and see what explodes first. Okay, heater is now on high. I'm not sure if you can see that amp meter, but it says 118.5 amps now. And I'm going to turn on this table saw and we'll see what happens. All right, it powered both of those things, the heater on high and my table saw, both at the same time. And we got a max amperage of 212 amps. So that's roughly 2,700 watts. Okay, so we're just gonna go for the full gusto. But we're gonna do the heater on high, we're gonna do the heat gun on high, and then we're gonna try to turn on this table saw, see if we can get some max amperage. Okay, now we have everything all plugged in. We have this industrial size plug right here, plugged in the heat gun and my floor heater, or my portable heater. And then I have the table saw plugged in right here. So I'm gonna turn on the heat gun, and then I'm gonna turn on the portable heater. That'll give us like 220 amps of continuous. And then I'm gonna try to turn on this table saw and see if we can push that amperage any higher. So let's go ahead and do it. All right, there's 93 amps. All right, the heater is now on and we're looking at 227 amps. And let's go ahead and turn on the table saw. We still only got a surge amperage of 227 amps. Now I know that we should have gotten a much larger surge. I mean, the surge of this table saw was what, 114 amps? Plus, if you add the 200 amps that were already going through it, I think it probably is because the voltage drops really bad. I'm not really sure, but I mean, okay, this inverter, it probably won't do it for very long, but this inverter powered a heat gun on high, a portable heater on high, and then it actually turned on this table saw as well. So, I mean, I'm sorry I couldn't grab the amperage that it was actually pulling, but I mean, this 2,000 watt inverter, I mean, we're looking at over, I don't know, I feel like it was over 4,000 watts. I mean, 900 watt heat gun, 1,500 watt portable heater. I mean, the unit actually said, I think, what, 2,100 watts just from those. So you throw in another 100 amps from a table saw, you know, you're looking at 3,200 watts. So, you know, even though I couldn't grab it all the way, I would say that this inverter can do a 4,000 watt surge with no problem. Okay, so what are my final thoughts on the 2,000 watt pure sine wave 12 volt inverter from Redodo? You know what? I'm impressed. It powered everything plus some that I thought it would. You know, it only uses a half an amp on standby. 2,000 watts can really power a majority of the appliances and items that you would need in a power outage situation. You know, it ran 2,000 watts for 5 minutes. Actually, it was about 2,100 watts for 5 minutes, and the unit itself really didn't get hot. The cabling did, but the unit itself did good. You know, it does have that small display on there. It's LCD, so it doesn't use much power to run it at all, which is nice. It's not like an LED screen. One of the down things that I can say about this is I like these terminal protectors, but I do feel like, I mean, they're just like a soft plastic. So I think over time they'll probably break pretty easily. I really don't know how you would get around that. I mean, you definitely can't use metal, and you can't, maybe like some sort of like stronger PVC or something. But these things are the one thing that I have a small gripe about. But besides that, this inverter from Redodo it does everything that you would expect it to. So thank you so much for watching this video. I just wanted to let you know that if you have any questions about this Redodo 2,000 watt inverter, I'll have a link in the description below. And if you have any questions you'd like to ask me, just go ahead and leave them in the comments and I'll be sure to get back to you. If you want to look at the manual, it will be on my website. You just go to off-grid-basement.com and look under the inverter section to find this inverter, more information about it, and that PDF manual. So thank you so much for watching this video, and you all have a great day. Bye-bye.